Hi, this is Gene with Troy Built Models, and we have an RF-70 in here, and we're going to take it out of here, put it together, and we're going to fly it around, do some precision ag work, and I'll show you how easy it is to use. Step one is we need to go to the center of the area that we're going to be flying at so that we can keep it within line of sight at all times. If there's any kind of incident where there is a manned plane anywhere in the vicinity, then what we're going to do is we're going to hit return to launch, and that's going to drop the altitude down as low as we can, and it's going to head back towards us, and we will avoid any incidents that way. Believe it or not, we can operate completely out of a Prius, so very simple to do. I've parked so that the back of the Prius is in the shade, so we can use the back of the Prius as a work surface. All right, the next thing to do would be to get out your RF-70 flight logbook and just start following along. You can download this on the internet. I print out several pages, put it in one of these kind of a binders so you can open it and close it and move these pages around. And because you're always in the wind, seems like I paperclip this in place. Also in here you should have your pre-flight, your checklist before you ever leave the home and the office, and you would put in everything that you would need to bring out to the flying field to do your job, because if you forget one little part, you're going to be really pissed off. So first of all, we're going to write in the location, then today's date, what the aircraft number is, you might have several of these, what the battery number is that we're going to be using. We're going to be using one piece of paper here for each flight. Who the air vehicle operator is, who the pilot in charge is. So you might be doing some training, so there's a pilot in charge and the air vehicle operator, the person who is actually going to be operating the transmitter. And then the trained visual observer, who that person is, write that in, and then the payload. We're going to be using the Canon SL1 for this because it's going to be precision ag. So then we're going to be going on to the pre-flight. First of all, we're going to figure out what the wind direction is, and it's coming out of the northeast. So it's coming out in the northeast, so we're going to go next and set up our bungee, and we're going to set the bungee up, and we're going to start down at the southwest and put that in so that it will take off towards the northeast. Okay, so what I did then was I walked about 22 paces, and 22 paces is about 50 feet or so, 60 feet in that range. And then that's where I dropped the ribbon or the parachute, whatever I happen to be using as a marker at the end. And then I unraveled the rest of the line and I staked it into the ground. And so you've got about 20 feet then of rubber tubing that's going to be stretched about 50, 60 feet. And then we've got about 100 feet of line, and then we've got the ribbon. And so what we're going to do then is when we're ready to launch, we're going to grab that ribbon and we're going to stretch it about 22 paces, which is about 50, 60 feet. So if you put a fish scale onto the end of it, you're going to see about 15 pounds of pull or so. And that's what you're shooting for. If you have 15 pounds of pull, that'll be enough to get it to launch okay. So we're going to hold it here, and then the trained visual observer is going to walk down, pick that up, stretch it, we're going to hook it on, and off we go. And the next thing we're going to do is assemble the plane. We're going to make sure that the wings are plugged in properly, and then we're going to install the battery. Okay, so the next thing on our list is to check our command and control transmitter voltage. So we're going to turn that on, and we're going to make sure we have enough battery here. So we're at 7.7 volts, so we're all set there. So we're going to write in 7.7 volts. Okay, the next thing we're going to do is we're going to check the voltage on our flight battery, and it's about 12.6. It's right around 4.2 volts per cell. So I'm going to write that down here. Flight battery voltage 4.2 volts per cell. And next thing we're going to do then is plug it in. All right, so now we will put our flight battery in place. I've already got it marked where it needs to go, and we're going to plug it in. Okay, we want to make sure that we've got a green light. This flashing yellow light here on the Pixhawk means that we don't have signal between the Pixhawk and the transmitter. So I don't have the transmitter on, just to demonstrate. So when we turn the transmitter on, it's going to, the transmitter talks to this receiver here. That receiver then gives information over to the Pixhawk, and this is going to turn green. Nothing's going to happen until that green light comes on. If that green light doesn't come on, it could be because your throttle trim is a little bit too low and you need to raise your throttle up a little bit. There we go. So now we have the green light. Okay, next we want to start up Mission Planner. And we want to hit connect. And that will connect now with our data link. And now we are connected. And we're going to check our voltage. And we can see that our voltage on our battery is 12.24. That's right around here. So we got 12.24 volts. Right now it's not pulling hardly any amps. And it does say 3D fix, which shows that we are connected. We want to verify the compass. We're looking at the aircraft here. It is where we think it is, and it is pointed in that direction. So looking at the aircraft, we can see that it's pointed kind of to the northeast. And then we can rotate it a little bit, and we'll rotate it a little bit to the north and double check that it's north, and it is. So we have verified that our compass is working. And then our radio link is up here. It says 99%. So that's the telemetry link. So we've got very strong telemetry link. This is on 915 megahertz. So actually this should be up in the air pretty high, maybe put on top of the car would help it out. But actually sitting inside of the back of the car, it's such a strong link and we're not going very far, it's going to work just fine. But it's better to have a longer cord on here and just put it on top of the vehicle, and you can use some double stick tape to stick it down to the top of the vehicle, and it would act like a ground plane antenna that way. Okay, so we're going to open up flight plan, and we're going to hit home location, and that will set the home location right where we are. And then we're going to create a grid. So we're going to just map out this little area here that's kind of in light gray, and we're gonna overlap a little bit, just go right outside where we actually want to get the imagery. So we're gonna right click, go draw a polygon, add polygon point, say OK, and then we're going to put another point here, and another one here, and another one there. And so we're going to drag these around again just to make them kind of square like that, and that looks pretty good. So now what we're going to do is we're going to go to auto waypoint and open survey grid, and we're going to choose the SL1 camera. Our altitude in meters, we're gonna just go to 122, and our flight speed is going to be in meters per second. We're going to go to 18, which is about 35 knots, or about 40 miles an hour. We're going to use that speed for mission, and the camera top is facing forward. So that means this is facing forward. The top part is facing forward. We are going to use the hot shoe extension, and we're going to use a GPS so that all of the photos then are GPS located, so it will be easier for our programming later to determine how to use the photo data. And so for the angle, we could change the angle a little bit, but looks like 0 degrees is pretty good. Now, the wind is coming out of here, which is the northeast, so we want to fly back and forth, and we want to fly into the wind. So we're going to angle this. We're going to come all the way around. You can see how things are changing. And we do have the Canon SL1 already in our database, so we can just use our drop-down menu. So here we go. We're going to fly back and forth. And we want to start down here, which is, so we want to start either at, we want to start at the bottom left. So we're going to go to Advanced Options, and we're going to go to Grid Options, and we're going to start from the bottom left. So we're going to start down in this area, so they're always going to be turning into the wind. So we got an overshoot of 50 meters, and we've got an overlap of 70% and a side lap of 70%. So this is giving us a total flight time of about 10.5 minutes. So that seems reasonable. This is where the photos are going to be taken, and this is the footprints of the photos. So we have a photo about every 1¼ seconds. Gives us a ground resolution of that. So right now we're going to write everything down on our checklist in this area here of all this information. So we did set our home point. We created a grid. Our altitude is 122 meters. Our angle is 131 degrees. Our flying speed is 18 meters per second. Our overshoot is like over here, and our overshoot is 50 and 50, and we're starting from the bottom left, and our overlap is 70 and our side lap is 70. Our area is 240,000 square meters. Distance it's going to fly is about 9.39 kilometers, and the distance between the images is going to be 23 meters. The ground resolution is 2.16 centimeters. The number of pictures we're going to take is 321, and the number of strips we got is 21. Distance between the lines is 34 meters. The estimated flight time is about 10 minutes and 52 seconds, and this is usually pretty accurate. And it's going to take a photo about every 1.26 seconds. So now what we're going to do is go back to simple, and we're going to hit accept. And so that's going to throw this over onto our flight plan now. We're going to save this waypoint file. We're going to call it A1 and hit save. We're going to write that down. And now we're going to go to the takeoff checklist. Okay, we're going to check that the motor spins free, which it does. There's not any sand and grit in there from the last landing. The props are tight enough so that when you push back on the propellers, they don't really fold all the way back. What you'd really have to avoid is if the propeller would happen to flip all the way like that and then in air, because what would happen if you started the motor up again, it would be way out of balance and it would actually tear the motor right out of there. So you got to make sure that these are fairly tight and they don't really want to bend any further back than that. Okay, so now we're going to go back to our laptop. We're going to verify that we do have the home point where it is, and it is correct. and then we're going to verify our start point, which is the bottom left. And so once we take off, we're going to make sure that after we hit auto, that it does head for point number 1. All right, so we verify the home point is accurate, which is where it's showing right now. And the start point is going to be bottom left. So what we need to do is upload the flight plan. So let's hit right waypoints. So it's written all the waypoints. So now we can go to flight data. And now it's populated our screen over here on the right. You see it says disarmed up here. We still have a 3D fix. We're in fly-by-wire. And I can flip the switch on the ground and
changed to auto.
You can hear it say that it's mode change to auto. And
mode
we do
to FEW.
want to be in fly-by-wire. That's fly-by-wire A. And so we're all set. And return to launch is off. I can check return to launch by flipping this return to launch switch.
Mode changed to RDL.
We want to have
mode
that off.
To FEW.
And so then what happens is that if we have any kind of an issue, we're going to hit this return to launch, and that will bring it back to us. Okay, so now we're going to verify the flight controls. The way we do that is have your visual observer. He's going to hold this so that the elevons are as level as possible. You might have to, it's usually pointed up like this a little bit, so got that level. And then we're going to go left elevon, check. Left one's up, right one's down. Right one's up, left one's down, check. Up, it's up, down, it's down. Okay, so that's good. And now we're going to verify that the fly-by-wire is working. And to do that, that's basically the stabilizer. We're going to roll the plane to the left. The right elevon comes up, the left one goes down. We're going to roll it the other direction. The left one comes up, the right one goes down. Go back to neutral. Now we're going to put the nose down. And the elevons are going to come up to try to balance that out. And then we're going to put it down. And so we verified that the flight stability is working properly. Okay, then the next step would be to check that the throttle's working. So make sure our prop is like that. And then we're going to say clear prop and give it some throttle. And you want to hold it to full throttle for about 2 seconds and make sure that it will maintain full throttle at 2 seconds. Okay, so now it's time to put in the camera. So we're going to set the intervalometer to 1 second. And for demonstration purposes, I'm not going to actually install it here, but we would set it to about 1 second. And it would automatically just start taking photos right away. So we don't want to take too many photos before we start the launch, but we'll put that in and button up the hatch, and we're ready to launch. And then we're going to check the CG. Marked on here, this is about 3 3/4 of an inch behind the rear front wing tube. And so we check it, and it is perfect. Ready. All right, so we've got our cord here, and we're going to take about 22 steps. We've already marked it off, so we know that 22 steps is back here, and then it has about 15 pounds of pull, which is quite a bit. There we go. I like to actually go to full up trim and then give it full up elevator. Make sure I'm in fly-by-wire. Return to launch is off. And I got my hand on the trigger, but don't hit it too early. Okay, let her go.
Trim center.
And off it goes. It's doing fine, so what we're going to do now is we're going to go to auto. Here we go. auto. And now the laptop is showing that it's going to auto, and we just keep an eye on the aircraft and watch it head for the southwest corner. All right, so now is a good time to complete our in-flight checklist. We've got our trained visual observer, and he's keeping an eye on the aircraft, and if there's something that goes wrong, we're going to go to return to launch. So first thing that we did was we attained the altitude. So on we could see here that we were about 120 meters when we were flying manually, and so then what we did was we flipped over to autopilot. Then we verified that it headed toward waypoint 1, and so then we have to note the time, the voltage, and the RSSI, and we could just keep an eye on that while it's flying. And then see what our average flight speed is. We did have it set for about 18 meters per second. This is showing a ground speed of about 13 at the moment, and airspeed of about 15. And now is when you keep an eye on the amount of amps that it's drawing. It's probably about 5 knot wind, so it isn't very high. It's drawing somewhere between 10 and 15 amps, so it's pretty low. We have a 16 amp battery in there, so it would fly for about an hour. We do have our battery voltage, and you can read that. It's 11.54, and we can keep an eye on that. And we want to land around 10 or a little higher at the very lowest. And then see what our altitude's doing. Our altitude's holding about 125, 127 in that range.
Waypoint 22.
Okay, so now we can start with the landing checklist. We want to check what the battery voltage is because we want to keep a note of that. That's very important so that you'll know when you're really running out of battery. Make sure the landing zone is clear. We're going to go to fly-by-wire mode. We know that it's time to land because it has stopped its course and it started to circle overhead. All right, so we're going to land. The landing zone is clear. We're going to land into the wind. We want to check our battery voltage before we land. It's about 11.13 because we want to note that. And so I'm going to take it over now. I'm going to put in fly-by-wire.
Mode changed to FEW.
And I'm going to just bring it around and land her in, and hopefully won't hit this BMW. Just like that, we missed the BMW. All right, so the next thing we want to do is disarm because the motor's still live. Press this in. Now it's disarmed. If we didn't have a folding propeller, we probably would have bent our shaft here. We want to turn off the camera, so I'm going to pop this open, turn the camera off right away so it stops taking photos. We're going to check the temperature of the motor, which is cool, and the ESC, which is fairly cool. And now we want to disconnect the flight battery. And the battery's cool as well. We're going to put on our voltage checker and check that battery separately and see how many volts per cell we have. We did check it, and it is about 3.9. And the last thing we want to do is note what the weather was, because if it's sunny and then cloudy and then back to sunny again, our imagery will be compromised somewhat. So we want to make a note. Today, in that 10-minute flight, it was sunny the entire time, so we'll note that. The other thing we want to do is with maintenance required. We're going to check everything out, and if there was any maintenance needed to be done, we want to write that on here right now. So then before we go on to the next flight, we want to check to make sure whatever that maintenance was accomplished before we take off on our next flight. And so that's it. We're done for the day. We can pack her up and off we go.